Welcome back. We're working on the third installment of the wiring diagram reverse engineering to understand the circuit so we can get it diagnosed properly. These are rewritten diagrams, so they're not factory, but these are what we pay to have access to. So this is a power window diagram on a 2014 Ford Explorer. We're going to go through, quickly identify all of the components on the diagram. You notice that right away this shows one of two. So this is a two-page diagram. So it's a little more complex than we've covered in the past. But that's okay because we need to progress to understanding more about the diagram so we can get on to more complex circuits. And this one is slightly more complex than the last thing we looked at. So this is the body control module, allows power to go out to the accessories through the accessory delay relay. And again, you can see that that's a checked box, so we know there's a lot more circuits that go into that body control module than just this one circuit. And we know that relay is hot at all times, and then when it's activated by the microcontroller in the body control module, it feeds power to the circuit breaker, which is a 30 amp self-resetting circuit breaker, and you can see there this is the symbol for the circuit breaker. So let's just go through the components quick. So that's the body control module. Here on the left, as we scroll down, is the master window control switch. You can see we have a ground G300 there in the middle of the screen, the left front power window motor, and then on to page 2, we have the passenger side window control switch, the left rear window control switch, the right rear window control switch, and then on the left side here you can see all three other window motors, the right front, the left rear, and the right rear. And then you can see about the right middle of the screen is G302, and then you can see each one of these switches has its own ground, but the passenger side, both the switches are grounded at G302. On the driver's side or the left side, G300 is the ground for both switches, as you can see there. So the first thing I want to cover is how do we know what wires on this page correspond to the wires on this page? Well, you probably already know the answer, but if you look on the left side of the screen, you can see the numbers at the ends of the wires on the left side of the page. This is on page 2. If we go up to page 1, those numbers correspond here on the right side of the page for page 1. And whether we're dealing with a 6-page diagram or a 2-page diagram, you would be able to print these out and lay them out and where these would all match up. So you can see here we have 1 and 2 on the right side of the screen on the blue wires. That is the power from the circuit breaker out to, well, page 2, right? So page 2 here is 1 and 2 on the left side of the screen. You can see 1 goes up and over to pin 1 on the passenger side window control switch. The number 2 blue wire comes over and feeds both pin 1 on the left rear and the right rear window switch. So since all these switches work similarly, we are only going to cover the passenger window switch just in the essence of time. I do want to show you a few different things. So first, let's just start at the beginning on the master switch, right? So it gets power off the circuit breaker. That feeds pin 3, and you can see here, power comes in here, feeds the LED circuit. These are 3 LEDs that are the illumination circuit for the switch. And then all of this goes through these resistors here, through the LEDs. There's some capacitors here, and then to ground, and you can see that the microcontroller in the switch also gets its ground through this circuit, and then out pin 1 to G300. So that's the ground for the master Windows switch. And you can see the integrated up-down switch for the left front switch directly controls the power and ground feed for the left front power window motor. So that one's really simple, right? You hit the switch down, power comes out on the down or the yellow and violet wire through the motor, and then to ground through the blue and gray back, and then the microcontroller either puts power on one side and grounds the other, or vice versa, to make the window go up or down. So pretty simple, pretty straightforward. We go up here, you can see that these are the other switches. And when these switches are actuated, they only provide power, because here on pin 3, this blue wire, the power comes in, down this rail, feeds power to the microcontroller, and then power out on pin 10, this yellow and green wire. And then pay attention to this yellow and green wire and this violet and white wire, because this is your lockout for your window lock, and then this is something else we don't know yet. But you can see it puts power out here, so this is important to understand that the power on this yellow and green wire comes from the window switch, or the master window switch. But you can see whenever you want one of the other windows, and we're going to look at the left or the right front, so we're going to look at this one here. Whenever we want the window to go down or up, it gets power switched to either the green and orange wire to go down, or the brown and yellow wire to go up. So now let's go to the second page of the diagram and figure out what is going on with these when power gets put to them. So we're on 7 and 8. We're going to go into the other diagram now. So page 2, 7 and 8, and if we follow these wires up, they go directly to the passenger side window control switch, and you can see the green and orange is down, the brown and yellow is up. So when we put power to the down circuit, power goes in here, hits this splice. It can't go past this diode because the diode is pointing this direction. So it's going to go down here through this inductor or solenoid, and it's going to create a magnetic field when current flows through this, through here to this splice, out, down, and over to G302 to ground. So we know that this green and orange wire, when it's got power on it, powers this inductor, which creates a magnetic field, which pulls this switch from here to here. And you can see this switch is normally switched here, which again comes over to this splice, down and to ground. So we know that both the violet and the white and orange wire are normally grounded by this switch here. So where do these go? That one says down, that one says up, so it's safe to assume maybe they go to the motor. Well, let's verify. They do. So they go to the right front power window motor. And you can see the motor doesn't just have the motor in there, you have the self-resetting circuit breaker. A lot of window motors have that because it's really easy to overload these when you hit your window stops. So that circuit breaker will actually open if you overcurrent that. So if we go up here, so we know both of these are normally grounded. So all it takes is one of them being switched to power to actuate the motor, because the other side's already grounded. So when this solenoid's activated, this switch gets closed, and then we have something, right? Well, where does it get its power from the switch? From the blue wire, which comes from the circuit breaker here. So you can see all of the current for the window motor is going to flow through this blue wire, through here, through this switch, to the motor, and then back through the closed side of the switch to ground, and then down to G302. So the only current flowing on the green and orange wire when you push the master switch down is whatever current it takes to make that inductor function. So, more than likely, since all it's doing is moving a switch, it's basically a complex relay that more than likely it's going to be a very, very low current on that green and orange wire. And then same on the opposite wire. So the brown and yellow, when power is put directly to that, same thing. It comes in here, activates this inductor or solenoid, creates a magnetic field, pulls this switch this way, feeds power from the blue wire down here through this switch, out the white and orange wire, through the motor, back on the violet wire, through here, through the normally closed switch, to ground at ground 302, allowing current to flow from the blue down here through this switch that gets activated by the brown and yellow wire, through here to the motor, back, and then back to ground. So, and then actually, what's pretty cool about this diagram is it shows these diodes that it doesn't absolutely need to show. And what those diodes are is when this field collapses and that switch closes, the magnetic field collapsing creates a voltage kick or an inductive kick, and this diode is how they manage that. So this diode actually takes that excessive voltage and allows it to go back through the inductor until it uses up all that voltage, instead of creating a large voltage spike that will typically burn the switch contacts, and we don't want that. So now, how does this switch work when I push the button? Because we see here that the down switch and the up switch aren't fed by the brown and yellow or the green and orange wire. They're fed by the yellow and green wire. Well, if we follow that yellow and green wire back, that's 9. Let's go to the first page, 9. We come over here, and that's power. Even though that power is on this rail, it gets fed by the blue wire, it comes, for some reason, it comes into here and then out through the master switch to the passenger side front window. And you can see the lockout here. Let's follow that out. So this is the violet and white wire comes up here and splits at this splice, and then we have 11 and 10. So we go down here to 11 and 10. So 11 goes up here to the left rear window control switch and feeds the same spot that yellow and green wire feeds. So when the window switch is locked, and here's 10 also, 10 goes to the same spot also on the right rear. So when the window lockout is pushed, it takes away the power to these rear switches, so you can't control those windows. What's unique about this is typically when you lock the windows, it locks all the 3 other windows. It looks like, according to this diagram, that you can't lock the passenger front window for whatever reason. But now that we know when that relay is active, so when we have power on blue, as long as the master switch is plugged in, we should have power on the yellow and green wire as well. And then when we activate our down switch at the switch, the passenger side window switch, it takes the power from the yellow and green through this switch, through here to our solenoid, which closes that switch and activates the window. And we already discussed how the rest of that works. So you can see there's 2 different ways, depending on where you're controlling this window, where it gets the power for the relay or the solenoid in this switch. And you can see this comes down here to the up side too. So you push the up button, same thing, closes this, activates the solenoid, pulls that switch shut, allows current to flow in on the blue wire, through out the white wire to make the motor go up, and then the current's going to come back in on the violet wire through this normally closed switch to ground and complete the circuit and allow the window to work. And again here you can see there's our diode, and that's a LED symbol with the little arrows pointing out, so we know that's an illumination circuit there, little capacitor and a resistor to make the LED work and function properly. And you can see that their other Windows switches are identical, so we're not going to take the time to go over those. Here you can see there's some inline connectors, labels on the connector. There's our pins for that connector. So say we want to look up one of those inline connectors for whatever reason, we can just go to it. And this isn't always the case, but these interactive diagrams are pretty nice, that a lot of times you can click right on the connector, and there's our connector pinout. There's the female side, the male side, our pinouts, our gauge wire, our circuit IDs, everything we need to know. And actually, it's not everything we need to know, because the main thing here that's missing that I'd like to see, that occasionally you'll see when you look these up, is where the heck is this thing? And we can go over that in a different video, but if you pay for service information, you can search this connector ID and location, and it'll typically get a location. Sometimes they even are nice enough to give you a nice diagram that points right at where it's at. But sometimes you get really vague locations and you just have to go look. I did want to cover a few little tips and details as well. So you see here, let's get zoomed right in so we can see really closely. So you can see these little half moon sections here. What that notates is this connector is going to have female pins in it, and the male pins are on the component. So we know, because this half moon is facing this direction, that the connector here, whatever, it's not labeled, but that connector is going to have female pins, and the male pins will be on that. And you can see here with the inline, we know the female pins will be on this side of the component, and the male pins, see the moon's facing the other direction, the male pins will be on this side. That's not always useful, but where it is useful is if you have a connector that is in an arbitrary location, like say those are in the kick panel, and I have both sides of the harness there, but I don't know which side goes to the window motor. I can look at the diagram and go, okay, well, the connector with the female pins more than likely goes toward the window switch, and the other side goes on the other side of the harness, goes the other direction. So, you know, like here, if I pull this switch apart and I check for power on the male pin, I should have power. I obviously won't have power on the blue pin with this connector disconnected. And I could look at it and go, okay, well, I'm looking on the male side. I don't have to waste time checking both sides and trying to figure out where the power should be coming from. So that's just, another tip to help save you some time and effort. That's probably all the useful tips and information on this one. You know, there's another circuit breaker. Yeah, that's probably it. That's a capacitor symbol there. These are resistors. There's a regular diode. That's the LED. But now that we know how this works, we can decide what's appropriate. Where do we want to test at, and what we need to do to make sure this works. For example, if the passenger side front window doesn't operate at the passenger side front window switch, but does operate at the master switch, then we know that we're going to have good power on the blue wire at the passenger side window switch, and we know we have connection on the green and orange wire and the brown and yellow wire. So now we know if we can operate that window from the driver's window switch and not from the passenger window switch, it eliminates basically everything except for, are we getting power on the yellow and green wire, and are the switches actually functioning in the switch? If that makes sense. I hope that makes sense, how simple this can be to diagnose if you understand how it works. I'm going to repeat that again just to hammer it home a little bit. So if the passenger side window switch doesn't operate the window, and the driver's side window switch, or the master switch, does operate the passenger side window, we know the blue wire has power because that's where it gets the current to operate the motor. we know the green and orange wire and the brown and yellow wire, if it'll operate the window in both directions, we know that power gets through on those two wires to activate the relay and the switch to allow the window to go up and down. So the only variable that leaves, and we know our ground's good because the window goes up and down, because it shares the same ground for that as it does for the relay. So we know the only way the passenger side window switch isn't going to function if the driver's side window switch functions for that window is either we're missing power on the yellow and green wire, or the physical switches in the window control switch don't function. I hope that makes sense. But again, that's why it helps to go through this step by step and make sure you understand how it works so you don't waste a bunch of time testing where you don't have to test, or doing, taking a bunch of stuff apart to test something that you can logically work through with a little bit of thinking, versus having to get out tools, take door panels off, pull switches out, set up test equipment. If we can just logically work through the system once we know how it works, we can save ourselves tons and tons of time. And this stacks. I mean, think about this. If you have 20 vehicles to work on this week, and you can save 45 minutes of messing around with this one job, you're going to make better time on every single one of those vehicles. You're going to be much, much more productive by slowing down a little bit, understanding how all this works, and then making a conscious, logical decision on where to test on the circuit. I hope this helps. If you guys like this video, subscribe, comment, let me know if you have any questions. If there's a specific type of system that you would like to see me cover, comment and let me know. Otherwise, I've just been pretty much picking these at random. I think the next one that we do will either be an engine system, either a complex body control system, or maybe a transmission. But let me know what you guys want to see. Otherwise, thanks for watching, subscribe, all that good stuff, and we'll see you in the next video. Thanks.